Guys, in today's video we are looking at trigonometry identities formulas, and we have to see where these formulas come from, which is deriving. Okay, this formula comes from Pythagoras theorem, which is like this. Angle triangle, you can create some formulas like this formula here can come from this right angle triangle here by using a Pythagoras theorem. Cot squared theta, it is equals to 1 over tan theta, tan squared theta. Okay, and we have also this one. So I'm going to show you where all these formulas come from, okay, by using this right angle triangle from Pythagoras theorem. Okay, we have to start with this one, which is the opposite of this capital A. We have small. By Pythagoras theorem, we start with this, which is a hypotenuse. Okay, so we're going to say A square should be equals to b squared plus c, this one c squared. Okay, from this formula we can say b squared plus c squared should be equals to a squared. So let's divide a throughout. So a squared, a squared, a squared, in which here you're going to remain with 1. You're going to have b squared over a squared plus c squared over a squared to be equals to 1. And from this expression which we have here, we can create this trigonometry identity which we have here, okay, which is sine squared theta plus cos squared theta, which is equals to 1. So we know that all these formula come from SOHCAHTOA. This is SOHCAHTOA, okay, like this. So we have to start with the sine. Okay, sine it is opposite over hypotenuse. Okay, so b squared over a squared, it is here. B squared, which is adjacent, b squared, which is adjacent over hypotenuse, which is cos squared theta. Okay, this is what I'm saying here. If you are lost, b squared, b here, and the cos, it is cos theta, it is equals to adjacent over hypotenuse. Okay, from adjacent over hypotenuse, adjacent we have b and hypotenuse we have a. This is which we have here. So we're going to substitute where this one here, b squared over a squared with the cos squared theta plus c, where the c squared over a squared c, which is opposite. This is our opposite here, opposite over adjacent, okay, which is opposite over hypotenuse, which is sine. Okay, this is opposite over hypotenuse, this is the sine here. So here see, this is the opposite, and the a squared, we have hypotenuse, which should be equals to sine squared theta, which should be equals to 1. You can write this equation either way by starting with sine squared theta plus cos squared theta, which should be equals to 1. Okay, I guess you're following what I'm doing here. Okay, now let's try to generate this formula which we have here from this, the very same equation. This is an important equation which can help you to find some of these trigonometry identity. Okay, so now let me try to create a space here. So now, since we say that sine squared theta plus cos squared theta, it is equals to 1. So now let's try to create some identities for cot squared theta should be equals to 1 over tan squared theta, okay, in which we can start by saying we divide throughout by cos squared theta, even here cos squared theta, even here cos squared theta. Okay, in which here you're going to have 1. So here your sine squared over cos squared theta, it is the tan squared theta, then plus here you have cos squared theta over cos squared theta, it is 1. So now tan squared theta plus 1, it is equals to 1 over cos squared theta, it is this one here. This is identity which comes out from this formula here, which is the sec squared theta. Okay, you can see this equation here corresponds with this one here. So where there's 1 over cos squared theta, you substitute it with sec squared theta, which means tan squared theta plus 1, it is equals to sec squared theta. We have generated one formula here. Okay, so now let's move to another formula. It could be this one or the first one here. Let's start by saying sine squared theta plus cos squared theta to be equals to 1. So here let's do vice versa by dividing throughout by sine squared theta by sine squared theta by sine squared theta. Okay, in which here you're going to remain with the 1 plus cos squared theta over sine squared theta. You are going to have cot squared theta, which should be equals to 1 plus cot squared theta, it is equals to 1 over sine squared theta, 1 over sine squared theta, it is cosec. So we're going to substitute here where there's 1 over sine squared theta with cosec, which is cosec squared theta. This is how we generate some formulas. If you are lost, let me try to help you understand here by saying, without saying here that there is a cot, so we can say 1 plus cos squared theta over sine squared theta over 1 here. Okay, so now let's look for a common denominator here. The common denominator is sine squared theta. 1 into sine squared theta, it is sine squared theta times 1. We are going to have sine squared theta, then plus sine squared theta into sine squared theta, this is 1. 1 times the cos squared theta is cos squared theta. Okay, and remember here, sine squared theta plus cos squared theta, it is equals to 1. So we can substitute here with 1. So we are going to say 1 over sine squared theta, and 1 over sine squared theta, it is cosec. This is how I come up with 1 plus cot squared theta should be equals to cosec squared theta. Okay, and now since we have generated this formula and this one here, I guess we have generated all the formula which it is written on this board. Thank you for watching. Don't forget to subscribe and turn on the notification bell so the next time you see the new updates. See you next time. Bye bye.